Surveying the surroundings at the edge of a black hole, you will see 99 versions of yourself. This isn't magic, but rather a photonic sphere, the most wondrous place in the known universe. Today we're tackling a downright sacrilegious topic. What would happen if you were thrown into a black hole? This is not science fiction, but based on real physics. Before I throw you in there, let's talk about it first. This black hole, which Einstein called a beast. What the heck is that? When a supermassive black hole, when extremely dense stars reach the end of their lives, he would collapse into a non-entity. There is no surface here for you to step on, nor any tangible entity. He will eventually become something called a starting point, a mysterious speck in the fabric of time and space. It is said that the density is infinitely large. Even gravity itself becomes infinite. Einstein's general theory of relativity, it truly overturned our understanding. Gravity is not actually a force acting on objects. To put it plainly, it's simply the mass of an object bending space-time. This theory perfectly explains, why does the Earth revolve around the Sun? What's even more interesting is that, why are black holes so dark that even light cannot escape? You see, when you stare at this black hole, there is actually no physical entity in space. Black surface, the true starting point hidden within, densely packed, bending space and time like a vertical deep well. In that case, nothing gets out of here, not even light is allowed. Why? Because, to escape from the clutches of this gravitational behemoth, you'd have to run faster than light. Everyone knows this. It's just not possible. When Einstein calculated this result back then, he doesn't even believe it himself. How could nature possibly allow such an outrageous thing exists? Back in 1939, he also wrote a paper specifically on the subject. The idea that stars collapse into a starting point is not credible. It simply won't happen in the universe. The funny thing is, in the very same year, Oppenheimer and physicist Hartland Snyder published a paper, Prophecy. Stars could indeed be crushed into black holes by their own gravity. The most amazing thing about the cave is, anything can become a black hole. Yes, I'm serious. Even you can. German physicist Karl Schwarzschild, the first to solve Einstein's field equations. This solution is particularly elegant and concise. In short, it's simply, whether you're a star, a planet, or a little person, simply set the mass m, compressed into the corresponding Schwarzschild radius r, bang, the birth of a black hole. For example, if all the mass of the Sun fit into a sphere with a radius of 3 kilometers, he turned into a black hole. The Earth would have to be compressed into a sphere with a radius of 9 millimeters, about the size of a glass marble. As for humans, it must be compressed to a size much smaller than a proton. But if it could really shrink that small, you really can be a black hole sometimes. I think it's time to send you into the black hole. But which black hole should we choose? Choose a small one. This seems a bit boring. How about something exciting? Check out these big guys. They're incident. The world is larger than our entire solar system. That's the mass of billions of suns. But that's just too much. Why not find one closer to home? For example, the supermassive black hole in the constellation Sagittarius at the center of the Milky Way. It's the first one ever captured by humans, one of only 2 black holes. We'll fly our spaceship over there, hovering 1 trillion meters away from the earthly world. Then I'll send you straight into the black hole. When you're in free fall, I'll be watching from the spacecraft. But here's the kicker. According to general relativity, the space-time near a black hole is incredibly warped. The time we experience will be completely different. To help you keep track of time, I'll give you a specially made watch. He can simultaneously show you the time you perceive, the time I observed aboard the spacecraft. Let's synchronize our watches first, then you can continue your journey to the black hole. After you set off, you'll see a big guy in the distance. It is voraciously devouring matter. Friction made it super hot. In reality, this accretion disk is actually bright blue or even white. However, to make it easier for you to see clearly, here we've deliberately set it to orange. You glance down at your watch for the first time. It's only been 30 minutes. You have flown to the vicinity of the event world. Approximately 0.1% of the journey has been completed. To date, the clock on my spacecraft is only 11 seconds ahead of yours. Now we're getting closer and closer. The warped space-time around a black hole started pulling off all sorts of magical effects, even light emanating from the sides or even the back of a black hole. The city will sneak into your eyes through every nook and cranny. Check the time again. You've been on your way for 2 hours now. The progress bar has reached 1.4%. My clock is already 44 seconds ahead of yours. But the shadow of a black hole, that black hole right in the middle, the expansion is happening much faster than we anticipated, or because of the gravitational lensing effect. Those lights that should have passed each other by, they all curve around and smash right into your retinas. After who knows how long, you finally glanced at your watch again. For you, it's only been 12 hours since I left. But on my end, the spacecraft's monitoring screen displays the image of you drifting toward the black hole. It has been going on for 15.5 hours. We're already very close to our goal, but things are about to get really weird. Before you reach the point of no return, you'll come across a place that's both strange and wondrous. If you could be in this magical place, let time stand still. After looking around, you'll be absolutely stunned. You have reached the photon sphere. This might be in our universe the most incredible place. This is a special region around the black hole. Here, gravity achieves perfect equilibrium, so light can actually circle around a black hole. Whether it's light emitted by matter or reflected light, photons will all stay obediently in their orbits. If this beam of light happens to travel tangentially, it can orbit around the black hole. But as long as the track deviates even slightly, the photon either falls into the black hole or just flies straight into space. Under these extremely exceptional circumstances, if you stop on the photon sphere, look around, you will see your own reflection, yet your gaze is fixed elsewhere. You'll see countless backs of your own head, all gazing into the distance. This isn't some high-tech trick. You truly saw another version of yourself, right by your side. This is the marvelous effect brought about by the distortion of space-time. As you continue forward, getting closer and closer to the event world, we have now passed through the photon layer. Black holes appear larger than imagined, almost completely filled the entire field of vision. I feel like I'm about to be swallowed whole by the darkness, because all the surrounding light was distorted. Not only can you see what's happening in normal space, even the shadows on the back and sides of the black hole. Everything is crystal clear. It's been 13 hours since you set off. In 24 minutes, you'll be traversing the event world. But aboard the spacecraft, I've actually been watching your journey for nearly 20 hours now. 18 minutes later, I glanced again. I've been observing you for nearly 40 hours now. For you, it was just a mere 18 minutes. For me, however, it had been a full 18 hours. The crucial moment has finally arrived. In 6 minutes, you are about to enter the event horizon of a black hole. Close your eyes and take a deep breath, glancing at his watch. But I found it seemed to be broken. Dial display. I've watched you fall for centuries. Actually, the watch isn't broken. The laws of physics are not wrong either. I have indeed spent decades watching you inch closer to the world of events. Later, your whole body began to glow red. I can only see you through infrared binoculars. Even if I could live forever, and will never see the moment you truly traverse the world of this life. For you, the final 6-minute journey, to me aboard the spacecraft, it seemed eternal. This sounds like science fiction, right? But this is the answer provided by Einstein's equation. Now you have entered the inner world of the world. Interestingly, it's actually quite difficult to accurately perceive. When exactly did I cross that line? You can still see the universe. You can see distant stars. You can even see our spacecraft drifting in outer space. But all these rays, including yourself, all are destined to fall back to the starting point. You have nowhere left to run. At that starting point of infinite density, the laws of physics will cease to apply. Time will also stop. To escape the gravitational pull of the starting point, you'd have to run faster than the speed of light. But that's simply impossible. Many people think that at this moment you would see the entire universe. The future unfolds before our eyes and fast forward. Actually, that's not the case. Due to the parallax effect, as you approach the starting point, the cosmos beyond will be compressed into a thin halo. Finally, when close enough to the starting point, your feet will be pulled forward by gravity. His entire body was stretched out like a piece of noodle. This is the famous pasta saying. At this moment, you and the black hole have become one, forever journeying together through the cosmos.